Hi, my name is John Capobianco, and today we're going to be looking at an MCP server for Cisco pyATS. Now, I started, my roots in artificial intelligence started in network automation and started with pyATS and connecting pyATS, which has parsers, which can get JSON, which has the ability to run configuration commands, a whole bunch of stuff. In fact, I wrote a book about pyATS. That's how much I love the tool and the framework. And MCP Server was a natural fit. So we're going to take a look at this, but essentially the MCP Server is going to advertise tools that it has and the required inputs for those tools. And how we've done this elegantly is we're going to volume mount the testbed file. The testbed file is required to describe the devices. And away we go. Natural language from there. Now I'm calling this Vibeops. Right? We've had DevOps and NetDevOps and AIOps. We're moving into Vibeops, where we're relying on MCPs and intelligent IDEs and tools and MCP clients. So let's take a look at this. I'm going to do some drawing first. So, all right. There's a lot to unpack here, but I have a LangGraph that I've built. LangGraph. Whoops, that's not centered. I have a LangGraph, all right? And I can show you what that looks like once we bring everything up and running. But we have this graph, and I have a front end in Streamlit that interacts with port 2024 for the LangGraph. And I start a thread, it gives me a thread ID, and then I can start passing it natural language. This is all NL. Now, the LangGraph ties into MCP servers. Okay, so what I've made is an MCP for pyATS. And this has access to tools of its own. Okay, and we'll look at those tools in a second. Tools. So the LangGraph reaches out and discovers the tools, and now this Streamlit natural language can ask questions about the network topology that these tools connect to. So let's draw a little bit further. These tools themselves, and let's just represent this as like a big cloud. This is the network, capital network. Routers and switches and different vendors and different APIs and different equipment. Those tools interface with the network. All right. Now the neat thing is, and I'm not going to draw them all, but let's make a few boxes here because I'm starting to really, so that was where I started with the MCP for pyATS and it worked great. Well, why not snap in GitHub? Why not snap in Slack? Why not slap in file system? Why not snap in service now? Same idea. LangGraph discovers the tools that all of these various MCPs offer, right? And they all have tools of their own. And those tools then reach out and talk to APIs or file systems or databases or whatever. And this is just a small subset. This just keeps going and going and going and going and going until we have, right, a hyper solution that we can just vibe code. So what do I mean by vibe coding? And let's take a look at this in action now. So I'm going to call up a few things. Let's go to the code first. And I don't need that code. So as you can see, it's all Docker based. So I have a bunch of folders and each of them represents a container. All of them are MCPs except for my LangGraph and my front end. But everything else you see here is an MCP server. And I have this bash script that builds all the containers and starts all of the containers, passing in environment variables as needed and things like that. So that's it. We're going to bring up the server. And this does take a little bit of time. So while the server comes up, I'm going to show you what goes into the pyATS code here. So we have the pyATS MCP server and the testbed file that we want to mock in. Now what's interesting is this testbed file, I have iOS XE devices. This could be 100 XE devices, 1,000 NXOS devices, XR devices, Junos devices, big IP from F5, you name it. We just build out this testbed. I don't have to make an individual router 2 automation or a router 1 automation. I don't need to handle the commands. I don't need to know the commands. I don't need to do anything other than describe my topology with my IP addresses and host names and credentials and pass it in. Now this could all be encrypted, by the way. There is an encryption mechanism if anyone's worried about that or looking for any gotchas here. That could all be encrypted. So all of the images are up and all the containers are up, and you can see that the Streamlit app is listing on 8501. And we're going to drill into the logs of this one. Is there any way to zoom in? I don't think so. So, all right, let's take it from the top. The LangGraph is coming up and is up and listening. And as part of this, we list all of the local containers. Notice there's no port numbers. Everything is STDIO, right? There is no port numbers here. And then we start discovering tools for these MCPs. So we're going to list the tools, and we've discovered some tools here from GitHub. All these GitHub tools. All right, now I want to find the pyATS one that I just built, probably at the bottom. Right, here we go. So, discovering tools from pyATS using tools discover. It's a JSON RPC2 call. And here's all the raw discovery and how everything works, all the doc strings and everything. Here are the commands. So run a show command, apply a configuration, learn the config, like show run, learn logging, like show logging, or ping something, running the ping command. All right, so now we have access to those tools. The other thing is, let's take a look at the graph to show you how this works, and we can even run this through the graph. So we're just going to click on this link and check out the studio here. And I just have to update the IP here. Hang on. All right, so this is the graph that I've been describing. And we have a RAG-based tool selection. So all those tools I just described to you are vectorized and embedded. And we do a semantic search to find the best tool for the job, which goes to the assistant, calls tools, we get the result, iterate through again if we need more tools. Otherwise, head back to the assistant and then end. Right, and we can actually prompt and test through here. But I'm just going to do it through my front end, through the Streamlit front end for now. So what we're going to do is we're going to say, can you help me analyze the running configuration on R1? It all happens pretty quick, but you can see the selected tool was learn config, and it goes ahead and learns the config. There's the config, the raw std output. It does it a second time here, which is okay. It might need more details or look at it a second time. And now we go back here and I have this, here's the this output is a Streamlit thing. I'll fix this. This is my front end, but sometimes the response comes back in this format. I'll fix it. But there's the running config, and then let's take a look at the analysis, right? Hostname, version, VRF, interfaces, and IP addresses, routing information, management information, security information, other information. Some great stuff here. So let's do a compounded one in the studio, and we can take a look at this. Now, hopefully this doesn't have any problems, but what we're going to try to do is say, as a human, can you take a look at R1 and R2 routing tables and give me a comparison. So we're going to run this, we're going to watch it in a few places. So we can see we're on the select tools here, and if we jump in here, we've selected learn config, which is interesting that it went to learn config and not a show command. But it's going to go ahead. Unfortunately, I don't have a tool. You do have a tool to do that. So let's be a little bit more specific here and say, can you run show IP route on R1 and R2 and give me a comparison? Now I'm going to fix this. I'm going to make it more sensitive to know that it has show commands, so I don't have to actually say the show command. That's not really vibe coding. But you can see the selected tools here are the run show command. So it's going to do it on R1 with this command. You can see we're in the tools now, right? So the assistant, the selection of tools happened. Back to the assistant, down to the tools, back to the assistant, and we're working our way through this loop. And then ultimately we should get a final answer and comparison between the routing tables. So we're down at tools. It's probably, and there's a little bit of latency because we have to wait for pyATS to scrape the routing table, right? So we're down back at the assistant, and it might have all the information and it's synthesizing an answer. Let's take a look. Let's see what happens next here. Okay, check this out, right? So if we really want to look at this, there's router 2, there's router 1, and the commands that it ran from the tool show run command. And then we have router 1's routing table, router 2's routing table, and a comparison summary. So it actually knows the link connecting these two devices. Pretty incredible stuff, right? So now let's move back into the let's look at LangSmith real quick and take a look at that waterfall again. So these are the logs on what's happened here, and if we waterfall it, you can see we picked the show run command, the show run command, and then we have the final generative AI answer through this waterfall. This took less than a minute. Less than a minute, all right? So let's go ahead and do something else. Can you tell me what interfaces are configured on R1 in a markdown table, please? And I'm leading to something, so just hang tight. And you see that collapsed and that fixed this output. I'm going to have to deal with that in Streamlit. So what we're going to do now is, what commands are going to run? Show run command, which is good. So it's going to do a show run, probably show IP interface brief or show interfaces maybe. We don't even care anymore what the commands are, right? The LLM is going to run the command with the right output, and we're just waiting for something to happen here. So there we go. All right, now the whole MCP idea, right? Let's take advantage of some of these MCPs. Could you please make a local file, let's say write. Could you please write a file called r1 interfaces.md in /projects. Now you're not going to believe this, but here's my VS Code, and you can see that there's no file here called R1 interfaces or whatever, right? There it is now. And there's the markdown, and I can view it as markdown, right? So a markdown table locally right from that command. Can I get a file? I'm going to say awesome. Can you now make the same file on GitHub owner automate your network repo packet conversations main branch with a commit of R1 interfaces. Now this is the GitHub repository, and in a couple seconds we should see a file created here. And now if I refresh the screen, there's a file right there, R1 interfaces, in Markdown. Okay, so that's GitHub. So now, awesome, even better. Could we now open a ServiceNow problem, short description, R1 interfaces, and long description listing the interfaces. Okay, so now here's my ServiceNow, and as you can see, there's no problems, right? And just in a second, right, tool selected, create ServiceNow problem, it's going to go ahead and make a problem here. So we'll wait for the Streamlit to come back and tell me that it's made the problem, and then we'll take a look at the problem. Okay, I'm going to say try again with ServiceNow, but do not use any markdown. Let's try that. So that's a prompting. Yeah, it didn't make the problem. So let's try it again. We got a pydantic error there because it's trying to put pipes and stuff in the description. So we'll fix that with a prompt. Try it again, but don't use any markdown. GitHub will take markdown. ServiceNow doesn't look like it'll take markdown, or we're trying to put some markdown in the short description. There we go. There we go. And if I go into my problems now, there's my problem, R1 interfaces, and there's my R1 interfaces in ServiceNow. I'm just going to clean up as I go. And not only all that, we can send it into Slack. So let's go ahead back here. Let's say incredible. Could you send it to my Slack channel? Now Slack is very fast. I should get this almost instantaneously. Some of the REST API tools are really quick. So there we go, right? There's the message. So pretty awesome stuff. Now, what haven't we done? We haven't done any configuration stuff. So let's refresh the screen. And just to show you I'm not cheating, because I'm not a cheater. Did I lose my... What's going on? Let me just refresh the CML here. Hang on. All right, so I'm going to do... Right, there's the show run. And you can see there's no loopback interfaces on here, right? Okay. So, could you create a loopback interface 100 on R1 using 172.16, 100 and 100/24 with the description of created by MCP and enable the port. After it is created, could you try to ping it locally from R1 to make sure it's up? I don't know, let's try that. So we should see some multiple tool selections here and run through a couple times. We should see it pick the, okay, so it's going to run ping. I don't know why it's running ping first. It's going to try to ping it. Okay, so here we go. Did I not have an apply config tool? Let me just check. Pretty sure I do. Maybe I need to be more explicit in the doc string. Just let me go up and find my tools here. What's that one called? Apply configuration. I'm going to say you should be able to use the apply configuration tool. No? There we go, apply configuration. So it gets a little, it's not, it's not perfect yet. I should maybe in my prompt, what did I say in my prompt? Yes, please proceed with configuration and then ping test. Please use the, hang on, there's two ping tools and I know it's going to get confused, so let's be explicit. Run ping command, not the ping tool. Ping tools for public IPs. Run ping command is running pings from the device. So we're working our way towards it. So see here, this is really cool. Tools selected is a list now. Apply config, run ping command. It's an array. It's a list that we then can iterate through to add some deterministic flows. So it really knows to apply the config and then to try the ping. So it's added the config. We can see here already, if I do a show run, I think it already added the loopback right there. Created loopback, it's enabled, it's got the right description and the right IP address. Now, check it out. Check it out. Okay, I have applied the config. There's the config. Now I have executed the ping, and here's the response. The ping was successful with 100% success rate, confirming the interface is up and reachable locally on R1. Okay, so MCP it's really legitimate, and it's beyond legitimate. Imagine if you will, like a super MCP from Cisco, which has pyATS, and it has ICE and ACI and DNA and Catalyst and Meraki and SD-WAN and Umbrella and on and on and on. Sub-MCPs, and we learn all the tools and we just drive everything through natural language. But because it's a protocol though, Juniper is going to have their own MCPs. So we tap into those. The Mist tools, the Junos tools, then Arista, and then F5, and then Palo Alto for the firewalls, and then ForcePoint, and then more and more and more, right? So this is really cool stuff, and it's vibe operating. Can you do this? Can you do that? How's this? Configure this. I'm not digging through piles of commands I need to memorize, and their syntax, and how to use them properly, and how to interpret the output. I'm just doing it all like a human would if these were human systems that we could talk to. So I really think that you should tune into Dwan Lightfoot and my MCP webinar coming up at the end of the month. Don't miss that. Follow Jeremy Schulman's work. Follow Dwan Lightfoot's work. Follow my work. Start your own MCPs. Start your own downstream MCP clients. Just start to use them and consume them. You don't have to build them. Amazing stuff. We'll talk to you soon.